Well, good afternoon. Welcome to COMP620 and COMP422 Information Privacy and Security. Today, maybe everything works. We'll talk about authentication. Got a reminder from the university that Wednesday, next week from today, is the last day to remove incompletes. So if you got an incomplete in the summer or last spring, grade of I, it will become a grade of F if you don't do something before next week. Hopefully you've been working with the instructor for the course to resolve that. But yes, so incompletes become Fs after Wednesday next week. If generally for an incomplete is a grade you can get, A through F, and then there's incomplete, and you should get it if for some reason beyond your control, you couldn't complete the semester. Somebody gets significantly sick and they can't come to class and they can't do the work, or they get hit by a car or something and they can't do the work. And then, yes, we don't flunk them because they didn't do it. We give them an incomplete and let them come back and do it. Okay, so that's an incomplete. So yeah, try to avoid them. All right. Authentication. Today we want to talk about the big question of authentication is, who are you really? You say you're this person, but how do we prove that that is you? Because often not only does it deal with humans, but it deals with other software entities that claim to be something or a particular software entity, a process or something, doing something, and it claims that it is this particular software with these privileges. How do you know that it's really that entity? And authorization, which is very similar but is different. Authorization is what you can do with that. But authentication narrows down to who are you? And today we're going to mostly talk about who are you as a human being. How do we know it's really you? For decades, we've been entering user IDs and passwords to validate who we are. When you enter the user ID, you're telling us who you claim to be. And then when you enter the password, you're authenticating, saying, yes, I really am that person because I know something. Okay, passwords have all sorts of problems. And even though many systems use it, they use it because it's very easy to implement. And users understand how to use it. Users have been doing it for a long time. They know all about entering their user ID and password. So we do that a lot. It still has all sorts of issues. Like it says, managing password security can be expensive. If you have a system that has user ID and passwords, you have to handle the problem of users forgetting their passwords. So you gotta resolve that issue. People need to be able to fix that. And again, it's not particularly secure. There are all these questions, which we'll talk a little bit later. How do you get the password of the user in the first place? What about password guessing and then compromise the password file? An important topic in passwords is phishing. Phishing typically occurs when somebody sends you an email claiming to be somebody else and says, oh, please send me this information. And believing that they are who they said they were, you send them the information. It is one of the most important security flaws in the system because humans often give out the information when they're asked. Somebody says, I have forgotten the password. That says, what is it? They'll send it to them if they think it's that person. So it happens a lot. We'll talk much more about phishing in a later lecture. So that's enough for phishing today. Phishing, again, is convincing the human to tell somebody the password. And that is probably the weakest point in passwords. People give them away all the time. Another problem with passwords is that people are not real good at making random passwords. They tend to pick passwords that are easy to remember. You saw the quote in the beginning, which said, if a password's easy to remember, it's not random. If it's random, it's not easy to remember. So people generally pick passwords that are very common. Here are your 10 most common passwords, which represent about 3%, about 10% of all the passwords, and 1, 2, 3, 4, 5, 6 turns out to be 3% of all passwords everywhere. That's just awesome. Important number here. Numerical passwords. Sometimes you're at, I go to the bank, to the ATM machine, it asks me for a PIN, a number to a personal identification number, and it's only 4 digits. You type it in, and people have studied what PINs, because the bank has a list of all of them. And so people have looked at this and found out, well, what are the most common? And it turns out the top 10 most common passwords, and of course, 1, 2, 3, 4 is probably the most common. The top 10 ones are used about 50% of the time. So 50% of the time, the password people enter are one from this list of 10. Okay. Another password issue is, how do you get the password to the person in the first place? Now here at A&T, there's a default password. There's a password that you use until you set your password. I think it's the first 4 letters of your user ID, if it's 4 letters long, and then the last 4 letters of your banner ID. I think that's it. That's your initial password. And in theory, only you know your user ID, and you're only supposed to know nobody else knows your banner ID. They aren't real secure. But other systems may send you your initial user ID and password. And of course, if the method by which they send you the password isn't secure, then your password is not secure. And here's our first question for today. I've got some, and I even have them out. Yes, it's online. And do it here in class. Think about that. Oh, sure. Everybody have their sticker item, okay. Return it when you're done, because it costs money. Okay. Oh, folks online are amazingly effective. Now we've got 73% participation online. Somebody always falls asleep online. Oh, you got, didn't I ever give you a plastic one?
I wasn't here when you gave up the most, I don't think.
Okay, well, here. Have a plastic.
Can I get one? I can.
Okay, this is your second one, huh?
Well, it's in here somewhere. I can find it.
Okay, yeah, I can relate to that. Oh, ready. Oh, that's no good. Sorry. Okay. Okay, online. Okay, 86% of the people have answered, and we are all ready to move here. Face recognition does not work 100% of the time. Okay, we're all set. We'll go try it here in class. Come on. There we go. All right, there, got you. All right. Okay. If you can make 10 guesses at a numerical password or PIN, what's the chance you can get access? Well, everybody likes, well, actually, online. Oh, yes. You can see the online results are 27% said less than 1%, 33% said 5%, and 40% of people said 50%. Here in class, the big number was B, 5%. Well, if you guess, not just random passwords, but if you guess the top 10 most commonly used passwords, since they're used,
Let's put a note there in case somebody.
since they're used half the time, you have a 50% chance of guessing, because 50% of the users are going to use one of the top 10 passwords. So if you guess the top 10, not just, don't just start off with 001, 002, do them as the most popular going down. Obviously, you start with 1, 2, 3, 4 and go down, and you should get it 50% of the time. So So unless people take care of their password selection, it's not very careful. Okay. Another interesting threat that works some of the time, but not as much as you think, is replay threats. Replay threats are, even though we have a encrypted system, if you send your password over a channel, I might be able to record this one. And then later, when you want to log on, I will replay what, in other words, I capture all the network packets that are going across, and later I send those network packets to the system, and it will be you logging on because you sent the right user ID, you sent the right password, and even though I might not be able to decrypt the password, the system will be able to. Now, this can be prevented by using HTTPS. HTTPS, which is a hybrid security system, creates a new password for communications every time you use it. If you remember about encryption, which is like a week or two ago, hybrid encryption generally starts off with asymmetric encryption. In other words, in using an asymmetric encryption, you send a AES or symmetric key to the other side, and then once you both share a symmetric key, then that's what you use for encryption. It's a different one. They create a random number every time. So if you're sending your password over the encrypted line, it's a new encryption key, and that doesn't really work though. This was much more of a threat before HTTPS became as popular as it is. I mean, even just 10 years ago, most websites are HTTP. Now they're almost all HTTPS because security has proved to be a problem. Other systems make other additions to just entry user ID. There is a system I use where I type in my user ID, and then it tells me a phrase that I have given it. And then if it's the correct phrase, then I enter my password. Because I don't enter my password until it verifies that it knows what it is. So if you go out to the website and try to log in, if you have a user ID and password, it will say your phrase. But when I try to log in, first it says my phrase. So if I don't see the phrase that I'm looking for, well, I'm not going to log in because I don't know it's actually that site. We'll talk about spoofing sites shortly. That's another common way to get in. Guessing passwords is very common. This is one way to get in. We talked about convincing people to tell you the password, but you can also sometimes just use the extreme speed of computers these days and try to brute force, try all the possible combinations and see if you can find one that works. The textbook gives an equation to figure out how long this will take, but we won't go into that because it's pretty obvious. Exhaustive search is trying everything. Okay, you've got so many characters on the keyboard, the password is so length, it's just the number of different characters raised to the power of the number of the length of the keyword, and that's how many times. That can become a very large number very fast. I'll show that in just a minute. Dictionary attacks, instead of trying all possible combinations, and of course, trying all possible combinations will eventually work because the correct password is one of the possible combinations. Dictionary attacks, again, are the idea of trying the most popular ones first. Try the ones that a lot of people use English words for passwords. I know long ago and far away, that we'd make the administrative password, and every week we'd change it, and we'd grab the dictionary, open it up, go there, put our finger on a word in the dictionary and say, that's the password for this week. Problem is, there's not that very many words in the English dictionary. While the number of characters raised to the power of the length keyword gets very big, very fast, there's really only about, well, depending on who you ask, some systems will tell you there's about 470,000 English words, of which only about 170,000 are generally used. So in everyday conversation, we can get by with 170,000 words. And so that's still a large number, but it's not very large if you can test each one in a millisecond or so, or just a couple of nanoseconds. There are several things you can do to reduce that attack. And we'll talk about those in a minute. Also want to mention about protecting the password file. So the system has to have all the passwords stored, either in a database or in a file. Commonly, in web systems, you'll have some sort of database, MySQL or whatever, and you'll do an SQL query asking to get the password for this user or to see if it exists, and if it's correct, here's to you. Now, you can just store the passwords, and then when a user ID enters, they give you a password, you go in your file, look for the password it's supposed to be, and see if they match. That works perfectly well, except if an attacker ever gets hold of that password file, they have everybody's password. Most common thing to do is to hash it. So, and the Unix, the passwords are stored in a publicly readable file, that / etc. / password, so everybody can see it.
Question.
Yes.
The user, does Unix allow the user to delete the password directly?
No, it's really.
It does not revert to.
That would really hurt. Yes. Yes. You can't read the file, then nobody could log in. Supposedly, also, nobody could, either could the administrator, which makes it really hard to fix. Okay, so instead of storing the password as characters as the user typed it in, a very common fix for this is to hash it using one-way hash. We talked about one-way hashes like SHA-1, MD5, or SHA-256, SHA-512. There's several of them, SHA being secure hashing algorithm. But there are several standardized hashing algorithms. SHA-1 takes regular characters as input, as many as you like, and produces a 160-bit or 20-byte hash. And that hash is saved. So then when a user wants to log in, the system takes the password that they entered, hashes it using whatever algorithm, SHA-1, and looks in their file and sees that the two hashed values match. The advantage of this is because it is a one-way hash, it is not feasible to, for a given hash, figure out a input or password that will do that. So users do not know what password. They can't just enter the hash value. Otherwise, the system will hash the hash value and get a double hash value. It doesn't work. So by hashing it, even if people can see what the hash value is, which you're probably trying to secure anyway, but if somebody got into your system and could see the password file or the database and get all of the hashes, they wouldn't be able to use it because it is not feasible to create a password that will hash to that. Now, even though they might not be able to do it, there are ways around it. There are dictionary tables. Dictionary table means you've taken a large number, possibly all the possible passwords, and you hash them all. And you save the results in a huge file. And then when somebody, and then when you find out the password that hash that somebody's using, you can take that hash, look in your great big dictionary table for the hash value. If you find the hash value, then you know what password created it. It's a trade-off between computation and space. Somebody spent a lot of CPU time hashing a whole lot of passwords to create a whole lot of hashed values. And so when you get the hash word, the hashed file, let me try it again. If you can get hold of the password file holding the hashes, you can then take a hash, look in the table for it. If you find it, then you know a password that enters it. By the way, it should be noted that there are multiple passwords that will hash to the same value. The SHA-1 hash is 20 bytes long, 20 characters. If your passwords are rarely 20 characters, if your passwords are 10 characters, then it is possible that there are passwords that will hash to the same value. So it may be that somebody finds out a password that works. It isn't the password that you actually use. There may be two passwords that work. That's not a problem because it's very unlikely in real life. But for dictionary tables, whatever it is, it gives the user a workable password. Now, this file can become very large because if there's I got a table in a minute, I'll tell you how large it is, but it becomes very, very large. There are ways of making it smaller. Rainbow tables are a technique for making the file smaller. You look up information, and then once you find information, you have to do some calculations to find the right value. It's explained in detail in the textbook. Another way to make the password file difficult is to use a salt. A salt is a random number. Notice we mentioned salts as initialization vectors and encryption. Same concept here. We have a random number. In this case, you just append the random number to the password and then hash it. Now, Wikipedia tells me the salt value is not secret. It may be stored with password hash. There are some problems with that. If, though, you're trying to protect a password file for everybody, for all user IDs, then you don't know what the salt is. And that just makes the password much longer. And even if they find the password, there may be many, many more values. If you use a 12-bit salt, 2 to the 12 is 4096, means there's 4096 possibilities. But why stop there? Why not use, like some systems do, 128-bit salt? Well, 2 to the 128 is a huge number. And no computer we have today or will have in our lifetimes can solve that computation in our lifetime. So it's very secure. Things you can do as a user to make your passwords stronger, to make them more secure. Basically, use long passwords. Here's the table I was mentioning that shows you how many possible passwords there are, given if there are only 10 numbers. If you have a password that's just 10 numbers, then how many have you? If it's, meaning there are 10 possible numbers, you can pick the numbers 0, 1, 2, 3, 4, all the way up to 9, and it's 4 long, well, then there's only 10,000 of them. It's 6, there's 1 million of them, and 8 characters long of this number, it's 100 million. If you use all the alphanumeric characters, that's all the uppercase, lowercase numbers, and the 10 letters. This is 26 letters in the alphabet. 2 times 26 is 52. Add 10 numerical digits, and you've got 62 values. If you just use those, then a 6-character password, there could be 5.7 times 10 to the 10 possible passwords. That's a really big number. Not as big as if you picked every possible character. I counted on my keyboard. There are 94 keys on my keyboard. Somebody who said 96, well, I couldn't find the other 2. So there are 96 keys on my, or 96 symbols on my keyboard. Or if you use all 94 and you have an 8-character password, then there are 6.1 times 10 to the 15 possible combinations. That at this time is very difficult to brute force. You're not going to do it with your laptop. Now, 4 characters, 62, a 4-character password, that's alphanumeric, 1.5 times 10 to the 7th, that's 15 million. Yeah, you could write a program that would do that. That might, it might take a little while, I mean, a few minutes to run, but your laptop's fast. You can do that. And if you got smart enough and figured out that, this can be done in parallel, you could use, your laptop's got quad processors. You could use every processor. You could use your laptop, the other laptop, that desktop down the hall. A common thing to do is go into the lab and use every computer in the lab and get it done. So yes, some numbers are feasible. 6.1 times 10 to the 15th is very large. That would be difficult. And of course, so as you can see, the longer the password, the better. The more characters you choose from, the better. That's why a lot of systems tell you to pick a password. It has to be an uppercase letter, a lowercase letter, a number, and a symbol. That's a very common request. They say symbol, but sometimes they don't always mean every symbol on the keyboard. And blanks frequently are not used. They may be used in the middle of a password, but some systems will trim them off the ends. And so that's usually not allowable character. Although, if your system allows blanks, putting a blank on the end, nobody will see it. Okay. And of course, don't do like we did and pick a word out of the dictionary. Don't pick your girlfriend's name or something like that. That doesn't work well either. Okay. Well, some systems, in order to prevent you from guessing, every time you guess, they increase the length of time to respond. So they have an artificial delay in the response. The first time, so you guess once and it gets it and figures out in a couple milliseconds what the answer is, but then it waits a second and then shows you what the answer is. If you guess wrong, next time you ask you 2 milliseconds. After that, or actually 2 seconds. After that, 4 seconds, then 8 seconds, and more time. Well, some systems just add a fixed amount of time. And of course, some systems, if you guess too many times, will lock you out. Yeah, that can really irritate certain professors when they're trying to do a Zoom class, and it locked me out. Yes, it doesn't always make. Yes, there was if you read the textbook, it tells you a story where the administrator missed the password to the root password 3 times and it locked him out. How do you fix that? You're root, you can't log in. You have to reboot the system. Okay, so here, this is actually a math question. Let's try this one. Stop sharing. All right, people online have got it. Right, take a look at this. No calculators allowed. There's an easy way to understand this one. I've got 2 online people who know their math. All right, everybody here figured it out? That's okay. Hold it up right there. Yeah, it's kind of sensitive to rotating the card because obviously you got to keep your fingers. So there we go. All right, we got it. Okay, what do we have? 63% participation online. Anybody else want to guess online? Oh, very good. We're getting some people woken up. I know. All right, then. Popular guess online is 1,023 seconds. Here in class, B for 20 seconds. Nope. First one's 1, then 2, then 4, then 8. Think of a binary number. You're setting the 1 bit for every digit, and you have 10 of them. So 2 to the 10 is 1 followed by 10 zeros. 1 less of that is 10 1, so it's 1,023. Yeah. All right, so whoops, just went backwards a bit.
Can you explain it?
Excuse me.
You go wrong with it.
Oh, why that's true?
No, why it's good. Just go right one more time.
The math?
Yeah.
The math.
Yeah.
Okay. Think binary numbers. The binary digits, the rightmost digit in a binary number is 1, 0, 1. Then the next digit is 1, it's 2 to the 1, which is 2. So if you have 1, 1, it's 3. Binary. Then the next digit is 4. So if you have 1, 0, 0, it's 4. 1, 1, 1 is 7. It's because it's 4 and 2 and 1. Add them together, it's 7. So if you have 10 of them, so you have the 1, because your first guess was 1 second, next guess was 2, then it was 4, next guess is 8, then 16, 32, all the way up to 512, and you add them all up, it will be 1, and you get a number, you get a binary number that's all 1 bits. Where you add 1 to it, it all carry into the next one, it would be 1 and 8 zeros, which is 1,024. Subtract 1, it's 1,023. Got the arithmetic? Oh, gee. Okay, hang on. Sorry, you just sneeze at something and it's going to. Okay, so we got that question. All right. Oh, sorry, I didn't show you that. Just told you, people did well. Okay. All right, cached passwords. Frequently, when you go to log into a system that you frequently use, when it comes up to the user ID password phrase, it'll fill your browser or the operating system will fill it in for you. I got a lot of sites I go to, and I don't need to bother logging in. It just puts my user ID and my password there. I just press enter or log in, and it works because my browser has remembered my user ID and password for me to make it convenient for me. On the other hand, that means somewhere in the bowels of that program, it is saving the user ID and password. And if a user can find the user ID and password, I don't know if it's encrypted or not, but if you can get access to it, it's there on your system. I wouldn't be so worried about people sitting there in the front, but what if something comes in over the web and has enough intelligence that runs a program on your computer and has enough intelligence to be able to do that, figure out where they are, it will get your user IDs and passwords. People tell you not to do it because obviously it's a threat. Also, if you are not in front of your computer, if I walk away from the computer to go do something, somebody can come up here and use my computer and log in. They don't need my passwords right there. And then there are other systems where the information is stored in a cookie. And we'll talk about cookies later on, but a cookie is information that the server sends to you, where it doesn't even show me the user ID and passwords screen. As soon as I log into it, it says, oh, I know who you are. Welcome back. Here, buy this. They always try to say something. Now, there are tools for Windows that will recover passwords. I went out searching for password recovery. You can find all sorts of tools that you can buy or possibly even use for free. Typically, you have to write the program to a USB drive or a CD and then boot the CD or the USB drive. So you have to close your computer, boot up off the USB. And typically that also requires you to go into your BIOS and say, I don't want to boot off the hard drive, I want to boot off the USB. And then it boots that program, which will search through the files. It knows where to look to find the password and can tell you what your password is. So it's not as secure as you'd like to think. So when your computer is turned off, you think nobody can get to it. No, somebody comes with their thumb drive, plugs it in, turns on your computer. Now, one thing you can do to protect your computer is tell it to always boot off the hard drive and not boot off any other media. If you need to boot off another media, for some reason you want to do something from different media, then you can go into the BIOS and change the boot order, specify another device. You need to put a password on your BIOS so that the attacker can't just sit down and do that for nothing. So if you have a password on your BIOS and you have it set to default boot off your hard drive, then you're safe from that. Okay. Forgotten passwords. Oh, forget things all the time. Wait till you're, what, 50 years older, you'll forget things. Happens a lot. Forget the passwords. Yes. So people forget passwords. And if someone forgets the password, there has to be a way to recover it. So I had to go out to Zoom and ask them, please, pretty please, let me reset my password. Typically, they do not tell you what your password is because, of course, they stored it as a hashed value and they don't even know what your password is. But they'll allow you to reset it. So they'll send you a link, click there, and put in a new password, and it will store the new password. So how secure is the password reset system? Can anybody go out there? Because you don't need to know your password to reset it, because if you knew your password, then you wouldn't have that problem. Most of them require you to be able to read your email. So it assumes that your email is secure. But if your email is not secure, then somebody can get into many other systems that you access by going there and saying, oh, I forgot my password, email me a reset. And then if they have access to your email, they can then get that link, which is usually customized to be you for this one time. And frequently they have a time limit on it. It'll work for the next 10 minutes or so. Click there and get into whatever systems they think you might access. There are also phone systems that are very similar. If you forgot to call up, a lot of them ask you questions. What's your mother's maiden name is a common question. I have a secret persona that I use for all these questions. I never tell them my mother's maiden name, but I have a name for my secure mother's maiden name that I use every now and again, but it's not the real. It's one I can remember. It's not real because it may be easier for someone to find out my mother's name. For instance, my sisters both know my mother's maiden name. I don't know if I trust either of them. So yeah, that's not good. But I know the one I tell them, and they don't know that. So that's something to think of. And of course, some systems require you to call up and talk to a human being and beg and plead and say, please set my password, which they may or they may not, depending on how they feel that day. And of course, back to getting passwords. You don't have to guess the password if you can convince somebody to just tell it to you. That's kind of part of how the forgotten password works. Now, the way you can get people's passwords, particularly on public computers like a lab computer here on campus, is you write a program that displays the password screen. You look at the password screen in the lab and you say, oh, this is what it looks like. You don't even have to be very careful. You just copy that, and then write a program that displays that on the screen. Gives a little, I think the usual one has a pull down menu that lets you, log into engineering, log into employee, same thing. And have the user enter their user ID and password. You start up in your user ID. Start up on your user ID and then put your program up there. Your program displays the login screen. Somebody walks in, sees the login screen, fine, they type in the user ID and password. Your program then stores that in a file someplace and then logs off, which of course forces the real logon screen to come up. So you goes, what happened? I thought I entered right. So log in again and away they go. Meanwhile, you've got their user ID and password. That's a pretty tricky system and it's been done a lot. Okay. We talked before about logging in with encryption. This is how it works. Alice wants to send a message to Bob, or Alice wants to log into server Bob. Alice sends a message to Bob saying, or the server saying, I'm Alice, and here's a random number that I just created. Bob will then send that random number back to Alice using the symmetric encryption key that both Alice and Bob know. And then Alice will send that random number, a function of that random number, say subtracted one, encrypted with her key, back to Bob. And now Alice is ensured that this is Bob they're talking to because Bob could encrypt the random number. Any other number Alice wouldn't accept. And Bob knows this is Alice because she could decrypt the number that was sent and then do a function on it and send it again, encrypted with the proper key. The key can be created from a password. So the user enters a password. We talked about converting password into encryption keys. You don't just use the 8 characters that the user typed in. The easiest thing to do is to run it through one of the hash algorithms like SHA-1 or SHA-256, whatever you feel like, perhaps multiple times until you get this great big, looks random, but it's not because it was created from your password. And you take those bits and use that as the encryption key. Okay. Now, the whole sum of this thing to remember is that just because they know the password doesn't mean it's the person who say they are. It just means it's somebody who knows your password. So if they enter your user ID and password, that verifies that the person there knows your password. Doesn't verify that it's you, verifies that it knows their password. And that's important. At this point, we're going to pause for just a couple of minutes and switch. Whoop, here's okay. Hang on there, online folks. We are going to talk about the exam. Hang on. Let me get to. And we'll share our screen. There. Hopefully the folks online can now see it says exam 1 results.
Yes.
Thank you. Okay. All right. Here's the grading scale that I use for this class. It's in the syllabus. This is the grading scale for the undergraduates for the COMP620 class. The only difference between that one and the grading scale for the graduate students is graduate students cannot get C-, D+, or Ds. I don't know about certificate students, whether they can get, let's just don't make me look it up. Just don't get a C-, a D+, or a D, and we won't all worry about it. Okay, here are the results from the exam. All 64 students who took the exam, I think. Generally, I thought it went pretty well. The most common grade was an A, and it goes right, you can see it just goes right down, sloping down, A, B, C. The plus and minus grades have a smaller range. There are more numerical scores you can get that will give you a B than there are that will give you a B+ or a B-. So even if the scores were uniformly distributed, you'd imagine more B's than B+ or B-. So there it is. There were, unfortunately, a couple F's, D+, and I've been talking with some of those people. Let's see what we can do about that. Now, the certificate people have been concerned that they not have the proper background for this class. I have been trying to make this class work for people of a great variety of background. In this chart, the blue box represents the, well, the blue, all these charts, the lines going up and down are the range of scores by that group. The blue on the left is the students of a bachelor's degree. I think there's one student, one or two students in COMP620 who have a BS. The middle or orange students are the certificate students, and the gray students are the master's students, both master's of computer science and any other master's program they might be in. You can see that the bachelor's degree has a wider range. The bachelor's and certificate students have a very similar average. The average is just like a point or two difference. Using statistics, one cannot say with any kind of reliability that one mean is better than the other mean. If you know, at 95% confidence level, or even at an 80% confidence level, you can't say one is better than the other. So the undergraduates are not necessarily doing better than certificate students. On the other hand, the master's students are doing a little bit better than the undergrads, and a little bit better than certificate students. And I should hope they are. I mean, if you're working on a master's degree in computer science, I hope you know a little bit more than the bachelor's students. Although not necessarily, I happen to know a lot of undergraduates who are much better programmers than the graduate students. But the good undergrads will hopefully become the graduate students. So there's the score. And again, looking at the scores, yeah, I know people don't like to get C's, particularly if you had to be a graduate student, but there's a lot of students. Also, remember, exam one counts for 20% of the semester grade. 20% of the grade is from assignments. There's 3 exams, 3 times 20 is 60, finals another 20, that's 80, and then the assignments. Now, there were some common issues in the exam I just might want to cover. One of them was a question that talked about the difference between the electronic codebook mode and the cipher block chaining mode. Which one was better and why? Well, here is the electronic codebook mode, where each block of plain text is encrypted to a block of ciphertext. It's done independently. And the problem with this is that patterns in the plain text, repeated blocks of plain text will produce the identical blocks of ciphertext. So an attacker can notice that different ciphertext blocks are identical, and therefore they know that certain plain text blocks were identical. With cipher block chaining, each block of plain text is exclusive ORed with the previous block of ciphertext, and so you don't know that even if you encrypt the same thing multiple times using the same key. If you use a different initialization vector, it comes out different every time. Now, Here's a question that I want to ask everybody. Oh, gee whiz, sorry. There we go. This is a question I'd like to ask. So let me get back. So let's see if I can get this poll going. Okay, online people can see it and the in-class people can see it, so. All right. It's a true or false question, yes or no, unless of course. Oh. Got it. Wait. Okay, got them all. All right, the online people, it's almost a tie. Okay, anybody else want to click? There, anybody else online? Got a low participation on this one. I can tell you, not a lot of people know the answer because I read all the exams. Okay, the answer in class is a bunch of B's and some A's. More B's than A's. Here online, there were more A's than B's. Well, the answer is that yes, it can be done. It can be done in parallel. Let's take a look at this. Here's the encryption. Decryption is just reverse. Imagine you're starting at the bottom. You just take the ciphertext, you run it through the decryptor with the key, and out comes the plain text. You can do all of them at the same time. You could take every block of ciphertext, decrypt it at the same time, and get blocks of plain text. So it can be done in parallel. A lot of students tried to tell me the wonders of CBC was that it could be decrypted in parallel. I'm like, well, that's nice, but so can electronic codebook method. Also, there was a little confusion about stenography. I put this example up because I stole that from Wikipedia, and I thought it was nice. But that's not really, deleting all the bits except the last two and making it better is not how you store information. Here perhaps is another example of how to store information in a picture. This is steganography. Here we've got 3 bytes. There are 8 bits in each byte. There's a red, green, blue, RGB, specifying the color. This gives you 3 times 8 is 24, which is 16 million different colors. And that's usually known as true color image. Lots of colors to see. Now, by using the lower 2 bits of each byte, since it's a binary number, the lower 2 bits are the least significant bits, are the ones that make the smallest change in a value. In other words, if you change just the rightmost least significant bit, you change the value only by 1. If you use 2, you change it by 4. So here's some examples of 8-bit values. You can see in this case, an 8-bit value runs from 160, if you made it 101010 ending 00, or ended at 11, it just ranges from 168 to 171, which is not a lot different. So the color produced where the red is 168 isn't a lot different from the one where red is 171. You can make it more subtle if you use only 1 bit per pixel. In other words, in this image, I only modified the least significant bit of the blue pixel, setting it to the data value from the text. Remember, the data value is going to be 1 or 0. The original pixel was 1 or 0. So 50% of the time, it was the right number anyway. You don't have to change it, so the color won't even be impacted in any way. And you don't even see it if I store lots of data in there. If I store 8 bits, this is even more. Here we have 2, 2, 2, or 6 bits. I did, I think, 3, 2, and 3, get 8 bits, and still I can't see it in the picture. Okay. So are there general questions about the exams? Anybody out there? If you have a general question, speak up. If you have a question about how yours is graded, let me know. Question about the answer, send me an email and I will try to explain it to you. I will, of course, blame it on the TA who graded half of them, but No, he did a good job, and I am responsible for all the grades. And so if there's a mistake, I'll fix it. Now, I wanted to talk about the research paper for the COMP620 students. That would be the graduate students and the certificate students. The COMP422 students can fall asleep for a couple minutes. This does not apply to them. Although I was thinking up an evil program for 422 this afternoon that you might see next time. Okay, you have to write a research paper. Yes, it's a graduate research paper. I need your personal opinion. It has to be your opinion. There are a list of 20 statements in the assignment. You go out, look at them, pick one that seems most interesting to you, and then either support it, say, yes, this is correct, or say, no, Dr. Williams is full of it. That's not correct at all. But you have to give your opinion, and then you have to back up your opinion. Isn't that because I think so? No, I want to see data. I want to see published opinions from reliable sources. Now, we have the web out there, and the web will tell you anything you want to see. I wouldn't call most of it reliable. That seems to be an issue in today's society, but we're not going to cover that at the moment. But anyway, scholar.google.com gives you information from scholarly articles. It's very useful. The articles themselves can often be found in the A&T library. If you can't get them online, you can look at them on the A&T library. If you log in from A&T, you can look at the material. A&T library has a tremendous amount of material online. It's available that way. They subscribe to many online systems. Notice that the research paper is due Wednesday, October 12th. You have lots of time to do that. If you wrote about 1 page a week, you'd be done. If you write 1 sentence an hour, you can be done. You have lots of time. Now, you have to pick the statement you're going to use. What statement are you going to support? What statement are you going to refute? And you have to let me know what your choice is by, what did I say, noon on Monday. So what is it? You've got about 5 days minus 5 hours. You have to pick one. So go out and look at them. They're all on Blackboard under assignments. Find the one that you really like and let me know. If you don't find one that really fires you up, but you have one that you'd like, let me know. I have already approved, well, sort of approved, pending approval on one. Remember, though, it has to be a statement that you'll either support or refute. I don't want book reports. Okay, so email it to me. There's also a limit on the number of students that can write the paper on the same topic. Everybody's writing the paper on the same topic. They're not all unique. In fact, the Internet of Things question seems very popular. I had no idea that would be it, but that's already maxed out. No more students are allowed to do the Internet of Things, but there are 19 other topics, and again, you can think of your own. Okay, some format issues. I need to be able to read this. Try to put it in something readable like Microsoft Word or PDF. Oh, yes, okay, 3 to 5 pages in length. You can put a title page that doesn't count as your pages. You can put a reference page at the end that doesn't count as your pages. 3 pages is not asking a lot. Single space or space and a half. Do not double space. Do not triple space it. Do not put 3-inch margins around the edge. I've seen all those. Yes, use 12-point font, please. Just 12-point font. Don't use great big font. No, eyes are still good enough to read 12-point font. Let me read those in 1-inch margins. Spelling and grammar count. Now, if you're using Microsoft Word and type in a word it doesn't know about, you'll put a little wiggly red line underneath it. If you see a wiggly red line, do not ignore it. Now, there are some technical words that Microsoft Word does not know. That's okay. The best thing, of course, is tell it to remember this word. But if you see a wiggly word, wiggly red line under a word, fix it. Because I will probably be looking at it in Microsoft Word, and I see a wiggly red line. I say, why did you take care of that? And you will lose points for spelling and grammar. Grammar also counts. Okay. Plagiarism. First of all, I'll tell you, I have lots of cool tools for checking on plagiarism. There are, university provides me a variety of tools to check and see if people have plagiarized things, and they seem to work pretty well. I have used them for years, and I will use them this time, so beware. When you if you read something, you go, oh, yes, that's really speaks to the topic. You can copy from that article and paste it in your paper. That's perfectly allowed. But if you do so, put it in quotes, separate it somehow so I know, and put a citation. The citation, usually square brackets, and then you can put a number. There's several citation formats. Most common ones are putting a number, and then at the end of the paper, you'll have a numerical list telling me where it came from. Or you can do something like Smith 22, which means it was written by Ms. Smith in 2022, and that's where it comes from. So if you copy something or almost copy something, yeah, you know, that's what they said. You just reword it in your own words and put it there. No, if it's somebody else's idea, cite it. Tell me what it was. You can't go wrong with citing it. If you have a paper and you took the information from somebody else and you cited it, that's nice. If you don't cite it, you plagiarize. Plagiarism is a sin. You cannot do that. So read your references. You've got 3 weeks or better to do this. Go out there, Google up. Wikipedia is a nice place to start. Lots of faculty will tell you Wikipedia is terrible. It's not. The most thing about Wikipedia is it has a list of references. Look at those references. Those are really good references. So you have to have 4 reliable references. And I have to tell a story. A few years ago, I gave an assignment. Students write paper. I had to write a 3-page paper. Yeah, it gave me 3 pages. The first page was entirely from Wikipedia. Second page was another website, and third page was the third website. Student didn't write a single unique word. They did, on the end, have a reference and tell me which websites they came from. No, that doesn't work. You can't do that. They didn't even cite it, just copied it. But my plagiarism tools were very good. Oh, this thing has been copied 100%. So don't do that. Now, that's why I need your opinion. I want your opinion. Okay, any questions about the assignment?
I have many.
Many? Well,
Unfortunately.
Well, okay, give me one.
Okay. So, okay, I guess I'll ask this. For our references, do they have to be, are you expecting them to be anything like MLA or APA formats, or do you just care to have like links to the
Any
website?
format you like is okay with me.
Okay. But I'm guessing you don't want to see just like a link to the website where we got it from. That's not sufficient.
If you identify it, give me, yes, okay, you can give a link. If you give a link, you've got to tell me, give me the title, give me the author or organization, give me the link, and hopefully it works. Usually if you see links in scholarly papers, they'll give you the name, the author, the title, the web link. They might even say verified on what date that you went out there and you actually checked it.
Okay.
Other questions? John, did you have more?
Oh, yeah. Sorry. I didn't know if someone else was asking one in class.
No, I'll go with you.
Okay. My second question was going to be, so I'm guessing then that you expect for the paper to have for the title page, or I guess the title and our name that has
I
to
don't
be
need a title page.
Okay.
Put your name on it.
Yes.
Don't forget to put your name on it. That would seem obvious,
Right.
but there's 60 some papers coming in. Somebody will forget. Put your name, and if you have a title, put the statement that you're supporting and refuting in there, so we know what you're doing, and your name. You can just put it at the top. Take a sentence or two. That's all. Or some people like to make it look longer and put a title page. Whatever you want.
Okay. Yeah, I wasn't sure, like a dedicated page for titles and references, or how you wanted that to go.
Any way you want it is fine.
Okay.
I'm loose. We can do it either way.
Okay. Those are the main things I wanted to ask. Anything else I will remember later.
Okay. All right. Anybody else have questions, statements? All right, let's continue to talk about authorization. Excuse me, authentication. Authentication. We talked about passwords. Beat that to death. Let's go on. There are other ways to identify you. A password is something you know, but you can also go, what do you have? Where you are, what you can do. What you have may mean you carry an ID card or a USB file or a telephone or something you have. That also lets you going to places where in order to get in the door, I had to put my card in, or maybe my card and a password to let me in. So you had to have the card. Where you are. Here on campus, you can't log into the university banner system unless you are on campus. Or I'm not sure if you can use the VPN to get in, but yes, you have to be on campus. You have to have an IP address or campus. Typically, these systems will check your IP address and see where you are. Or they can use global positioning system. A lot of systems, particularly if you're phone oriented, will take your position with the GPS on your phone and say, where are you? And if you're coming in from Kazakhstan, it says it's probably not you because 2 minutes ago you were in downtown Greensboro. This is probably not you. So they can do that. Not to pick on Kazakhstan, of course, but it's far away. Other things, what you can do. You can test people, things that you can do that are very hard for other people to repeat. Writing your name on a touchpad is something we've used handwritten signatures for millennia to identify people. You can also do it online. You all are going to write your name with your finger on the screen. It doesn't look a lot like my signature when I use a pen. It's a lot clumsier, but it's sort of like it. Interesting with keyboards, if you type a phrase that you are familiar with, particularly your name, if you type your name, how fast you can type your name is very unique to yourself, particularly the inner character timing. You carefully time when each character is pressed, then that looks different if somebody else types it. So if you type my name into a computer, you'll probably not type it at the speed, at the rate in which I type it. Again, it's not perfect, but it gives you a rough approximation. If someone enters my name and doesn't do it close to the speed, the timings that I do it, it may very well not be me. I might reject it. I might point out, I used to live many years up in the far north regions of this country, in Minneapolis and stuff. And it gets cold up there, real cold. And even if you're wearing your mittens, your fingers get cold, and your fingers get cold like that, they don't bend real well. It's hard to type anything. Never log in. Biometrics is a way, again, things you can do, things you are. And we just talked about keystrokes, and talk about voice, and then there's other things. Fingerprints are a very common way to log you in with biometrics. I think iPhones and iPads use fingerprints. Excuse me? You don't use that anymore? My phone uses facial identification, and I'd say it works 50% of the time at best. 100% of the time. Maybe I just have to redo my picture. Maybe I was screwed. I'll tell you, when you put your mask on for COVID, it doesn't recognize you at all. Although I've heard that some of the Apple systems are pretty good, even if you're wearing a mask, which, yeah, so, okay. Now,
My
it generally works pretty well.
if I'm wearing a mask.
Excuse me. Yes, online?
My 13, I have an iPhone 13 and it detects when I wear a mask.
Oh, good. Yes, mine does not. I have a non-iPhone, which I must admit is of lower quality. But Anyway, yes, so I don't know how different that makes people look. If you wear if you wear a hat, dark glasses, and a mask, it could be anybody. Some people don't have very usable fingerprints. I have a sister whose fingerprints do not show very well, it's smooth, and none of the fingerprint systems work for her. Now, you might note that a fingerprint system doesn't match at 100% because it depends on how you push the fingerprint down, whether you're if you move your finger at an angle, rotate it slightly, it has to count for that. And I mentioned iPhones. Microsoft Windows has a fingerprint manager now. If you plug a fingerprint reader into it, it will work. I've used fingerprint readers for many years. I might note that every few months, I had to reinitialize my fingerprint reader. That after a while, my fingerprint wear out. I don't think my fingers changed. I think the fingerprint reader gave a different reading. And of course, if you give the system your fingerprint, you're giving away information about you. I recently gave all my fingerprints to the TSA so they would allow me to have faster, pre-screen, TSA pre-check, so I can walk quickly through the airports. And they now have one. They may have had, it's the federal government. They may have had them anyway. Now, of course, you watch the movies, your finger doesn't have to be attached to your hand for it to work. Also, there are ways to forge rumors. Almost anytime you touch something, even if you touch a clean glass surface, you're going to leave your fingerprints. This is in the movies all over the place. Surely you've seen movies where somebody's handed somebody a glass, they touch it, they take it back, particularly if they happen to be at a reception or eating food, a little grease in their fingers, they leave wonderful fingerprints, they go back and they lift the fingerprints up there. If you go out and Google up gummy bears and fingerprints, you'll find a technique for using the chewy gummy bears to lift fingerprints and make usable fingerprints for fingerprint systems that they can log into your phone by putting the gummy on your phone. Now, typically in the past, the FBI has used fingerprints for decades to identify people. Is this criminal? It's a different system to find who are you? I have your fingerprints and I want to know who you are, as opposed to you say you're Ken Williams, put your fingerprint here and let me verify that. Verification is a one-to-one. Am I who I said I was? Or who are you? Who are you is a much harder question. You have to look, the FBI, I assume the FBI has millions of fingerprints and they have to match them all out. I'm sure out of millions, some people's fingerprints look very similar and match them together. Of course, that doesn't mean it's insecure, because how do you find somebody who has a fingerprint like yours? I'm not sure how you do that. So authentication can be a reject or accept, but you have to measure carefully. There are different types of measurements. We have false positives and false negatives. A false positive is that you allow the wrong person in, that they do a biometric. We'll pick on fingerprints for a minute. They put their fingerprint in, and I'll grab your phone that uses fingerprints, and I put my finger on it, and it lets me in. That's a false positive. And that, of course, is a major security problem. False negatives are where you put your finger on it, and it doesn't let you in. I've experienced that a lot with my fingerprint readers. Well, sure, every now and again it doesn't work. You do it again, it works. But I noticed after a few months, I'd try it once, no, try it again, no, try it like 3 times, and then it would work. So then I have to re-enter my fingerprints. It might be seasonal. In the winter, indoor humidities drop, your fingers dry out, and it might impact your fingerprints. So you have false negatives and false positives. So when you are determining how close do you have to be, because remember, it's not an exact match. You get the information from the person's fingerprints, and you look in the data file that you have that has information about the fingerprint. Now you're trying to match them up in all sorts of ways that fingerprint matching is done. It's not just an image. They carefully look at swirls and eddies and try to match them up. You have to say, how close are you going to get before you get a false? You have to look at what's the false acceptance rate. It's easy to look at this picture. This picture along the x-axis, how carefully are we matching the information? If we match it very carefully, meaning we're way over on the right, then only a really good match is going to make it. We'll get lots of false rejections. The FRR, false rejection rate, goes way up because unless it really matches carefully. On the other hand, the false acceptance go way down because the closer you match, the less likely it is that somebody else's fingerprint will look like yours and let them in. There is a point where they match. It's called the equal error rate, where both false acceptance and the false rejection are the same. And they note that most fingerprint systems are only about 1 or 2%. Of course, there are many other things besides fingerprints. Similar to fingerprints are finger vein recognition. Now, I've never seen one of these systems myself, but I've been reading about them. They shine a infrared light through your finger, and they look at the vein pattern in your finger, which I am told is unique to all people. That's what I read. They tell me that the vein pattern in your finger and through much of your body is unique, and so if they can look at it, they can see difference. And this works a little better than some systems. Again, it's not affected by race, skin discolorations, or age, so you should be able to look at it. And so that's an alternative to fingerprints, although you have to put your finger in so the light shines through your finger. There's facial recognition system. We talked about that for phones. A lot of phones use facial recognition now. Again, my phone has a lot of false negatives. It frequently doesn't believe I'm me, but yours may work better. I think iPhones work better than some of the other phones. And some of the phones have gotten around masks, which is interesting. I also think some societies where people often block their faces or portions of their face, how that would work.
It's not really secure. Another one that kind of mine picked up my phone. It was putting on a mask and my phone unlocked.
Yes, they always work. You can fool facial recognition. I had a grad student work on a system to work on this. It's quite easy. We tried it. Print out a picture of the user. And then when you go to log in, hold the picture up in front of the camera. Voila, it logs you in because it sees a beautiful image. And of course, it is the user. You take a nice picture of the user looking at you straight on. And even if you don't take one, you can probably find one online. There's lots of people. This is the age of the internet. You can find somebody's picture out there, find him, and put it up there, and it works. So how do you get around that? My graduate student worked on a system where it asked the human to move. Raise your right hand, turn left, turn right, look up, look down, which the system could record. And then if you did those things, then it said, oh, okay, you're probably right. Now, if you had a complete set of photographs of the person, and particularly for raising the hand, it might be a nicely Photoshop picture. You take the person's face, put it on you, you raise your hands, and that works. But you had to have a set of pictures to work, which might work. But we just found that we could at least prevent the simple things by asking the person to move in a certain way. Okay, speaker recognition. This is where you talk to the system and it listens to see if it's your voice. I have some system that I use, some system I go to, and if I go on, it asks me to repeat a phrase, which I repeated to it several times to initialize. And now, if I say it, it goes, oh, yep, I believe that's you. This is usually after entering my password. So it's used, again, with multiple things. I might point out, what if you have a cold? Laryngitis. You're never going to get logged in. Oh, we've run out of time. Doggone. Okay. A lot of people, department here, people working on looking at the irises. That works. Revoking biometrics. How do you can change your password, you can't change your fingerprint. And just because I got this file, so in a minute, look at this. Whoa, oh, come on. This is a movie from The Incredibles, and it's not going to play for me. Well, darn. Okay, too bad. We'll cover the rest of this later. We'll cover the rest of that later. Sorry, shoot, but Edna Mode uses about 5 different biometrics to log in. It's kind of funny. But work at my house. I wonder why it doesn't work here. All right, that's enough for today. Remember, send me the topic for your paper. You want to do this early because already one of the topics is used up. And if you really have a burning desire to do a paper on a different topic, let me know and we'll think about it. Okay. See you next time. See you next Monday.
Dr. Williams, I had a question about the
Yes,
test.
sir. Yes, your question. Mr. Armstrong?
Can you hear me?
Yes, I can. Can't hear you now. You're muted.
Oh, yeah, I'm trying to unmute. I'm sorry. So yeah, on the test, one of the questions said, Emmanuel has a medium clearance in a 3-level BIBA integrity model. What access to a document classified as high would he have? What access does he have to a document classified as high? So I
Yes.
thought in the BIBA integrity model, you can write up or no. Oh, I'm sorry. Yeah, I see where I was wrong now. Okay.
Opposite of the Bell Laputa model.
All right. Oh yeah, so that means you can read up and write down, correct?
That's correct.
So Emmanuel has a medium clearance, and it says that putting right as the answer is incorrect, and he has read access to a document that is higher for one of my questions I got incorrect, and then I got that same
Okay. I'll
type
tell
of
you
question.
what, send me an email identifying the question and I'll go look out online and see whether your thing was graded correctly.
Okay.
I mean,
All right. Is it fine if I just kind of screen crop the test and just send you that image?
excuse me, please.
Is it okay if I just kind of screen crop the questions and then send you that image?
So I have all the questions. I even know your answers. I have those too. So just tell me what question.
Okay. It was question 5 and question 6.
Could you send me an email, please? See, Graybeard, I'm not going to remember that. But if you would please send me an email, I will answer you and tell you whether we made a great mistake grading it or whether you just got all screwed up.
Okay. Thank you, sir.
Okay. Fairley. Mr. Fairley, you're there. See you. Still awake? Okay, well, Mr. Fairley, we got to get you to do that document signing. Sure, that's okay. Enough for today.